All right. So this page, which is the first page of the worksheet, if you have the worksheet, has some of the basic formulas for dealing with complex numbers, and also your how to convert things from phasor domain to time domain, so back and forth that way. Although the truth is, I don't really ever, there are a few things that I have memorized, and otherwise, I don't necessarily refer to these, which may end up being a problem because when I learned this, I might not have learned it the same way that y'all are learning it in class. So if I start doing something that seems like completely foreign or weird, say, that's not how Mr. Raveley did it, and maybe I can see what it is that I'm doing differently. Okay, so the first thing to keep in mind is that when you were in high school, if you ever studied complex numbers, you learned that the square root of -1 was I. Well, engineers don't use I, they use J, because especially electrical engineers use I for something else very important, and that would be current. And so to keep it from being confused, you're going to use J. I also take a lot of physics classes and math classes, so I have to change my letters when I go into a new building. But if I ever say I really, no, I don't want to say that, because if I say I might be meaning current. I'm going to try to be good and use J, but it's actually been a while since I've had an EE class where I was using complex numbers. Although you will have lots of them. It's just been a while since I've had it. Okay, so the first thing we're going to do is we're going to see that there are multiple ways of representing a complex number. So all complex numbers have a real part and they have an imaginary part. That's my sister, and I'm laughing because my sister just called me, for those of you who are online. When we used to teach together, we were both high school teachers, and she taught first and second hour, and then she left because she has a PhD, she's a professional in her field, and she just came in, did that, and then left. But hey Helen, I'm teaching right now. I'm not going to be done until 6. Is this important? Okay, I can call you during a break. Okay, all right, okay, fine. So she taught first and second hour, and she knew that I taught all day long. But I'd be in my third hour class teaching, and my phone would start ringing. And I'd be like, and she'd call me like as she was driving off campus, like every day. It's like, Helen, you know I'm teaching. And so we had the same thing right here. Okay, so complex numbers have a real part and they have an imaginary part. And they might not have one of those parts, but it might be 0. So one of the parts might be 0. And when we look at a complex number, we can graph it. And when we graph it, we'd say we have a real axis and we have an imaginary axis. And so when I look at 3 plus J4, my real part is 3 and my imaginary part is 4, so J4. So when I graph this, I would go over 3 on the real axis and up 4 on the imaginary axis. And that gets me a representation of this complex number. And so another way that I can represent this complex number is kind of thinking of it like a vector. So what I want to do is I want to figure out this angle right there, and I want to figure out the length of the vector. So the length is going to be, so if I have A plus JB, then the length of that, the magnitude, is going to be the square root of A squared plus B squared. And so in this instance, the length is going to be the square root of 3 squared plus 4 squared, or the square root of 9 plus 16, or the square root of 25, which is 5. So that's going to get me the magnitude. Now to get the angle, I'm going to take the inverse tangent of b over a. So in this case, it would be the inverse tangent of 4 over 3. Now, I have to be careful because my calculator is going to give me, when I do, first of all, you need to decide if you're going to be in radians or degrees, and I'll be in degrees for right now. So I'm in degrees, and I'll take the inverse tangent of 3 over 4. And I get 38.86. Now, the problem is that I would also... 36.86, thank you. Thank you. I need that because I make those mistakes. The problem is I would have also gotten that same answer. Let me write that. So theta equals, what was it, 36.86 degrees. I would have gotten that same answer if I had had negative 3 minus J4, because if I go negative 3 and minus J4, I'm down here, but when I take the inverse tangent, that would still be a positive number. And so you do have to pay attention to what quadrant your angle is in. And if the answer you get, so I got 36.86, that's correct. I look at that, that's in the correct quadrant. If the calculator is only going to give you answers in this quadrant and this quadrant. And if your complex number is actually in one of the other quadrants, then you add 180 degrees, or pi if you're in radians, to get what it is in that other quadrant. And we will see an example of that, so you can see what that is. Okay, so in polar form, then, we write this, so there's two ways that you can think about this. So this is 5e to the j 36.86 degrees, but a lot of times we just use phasors. And so what phasors do is phasors allow us to do lots of computations without having to worry about some of the things that are involved with adding, subtracting, dividing, differentiating sinusoidal functions. It kind of simplifies things. We convert to phasors at the beginning, and then we convert back from phasors, convert into sinusoidal functions back at the end. And in phasors, all we have to do, why do I have the wrong angle?
Hey, yeah. I got 52 degrees whenever I did.
Thank you, because I did 3 over 4 instead of 4 over 3. So, yeah, let me fix that. So I was supposed to do the inverse tangent of 4 over 3, and I did 3 over 4. So the inverse tangent of 4 divided by 3 is 53.1 degrees. So, so in phasor form, we just write this as, we put 5, that's our amplitude, and then angle 53.13 degrees. And by the way, when you use degrees, you should put a degree symbol. Radians don't have a symbol, so if it's degrees, you use a degree symbol. Okay, so I don't have my chat window open, so but I think I'd get a little notice if there were any questions in chat. So let me go on and do the next one, which is -6 plus j8. So -6 plus j8. So I want to see what quadrant it's in. 1, 2, 3, 4, 5, 6, and 8. So I see what quadrant it's in. So that's going to be the angle I'm interested in getting. So I'm going to have the square root of 36 plus 64, or the square root of 100, which is 10. So that gets me my magnitude, that gets the amplitude of my phasor. And then I want the inverse tangent of 8 over -6. And when I do that, you'll see the calculator will give you the negative answer, negative 53 degrees. So the calculator gives us negative 53.1 degrees. And the calculator is always going to give you an answer from negative 90 degrees to positive 90 degrees. Our answer is not negative 53 degrees. That would be down here. And so that means it's really 180 plus that. So I need to add 180. And if I was in radians, it'd be pi. And I get 126.9 degrees. So in phasor form, this is 10 angle 126.9 degrees. Now okay, this is an example of how I think the book does it a little bit differently. What they do, and it's equivalent. I just kind of like thinking about it in terms of quadrants a little easier. They take it in polar form, which would be Ej negative 53.1 degrees, and then they multiply that by Ej 180, and when you multiply, you add exponents, and that would give you Ej 126.9 degrees. But and I think that was I'm not sure. I think I saw that like in the book that's how they did it. But I just look at what quadrant it's in. And if it's in the wrong quadrant, I just add 180 degrees. Okay, now let's do the next one, negative 6 minus J4. And at this point, you don't necessarily have to draw it if you recognize that, oh, okay, that's going to be in quadrant 3. Because you go out 6 and down 4. And so we'll take the square root of 6 squared plus 4 squared, and the square root of 36 plus 16. And I think that is 7.21. And if I have the wrong number, if someone would please tell me. So y'all do need to check this because I do have wrong numbers. And then I would take the inverse tangent of negative 4 over negative 6. And it gets me 33.69 degrees. And you can see that that is not in the correct quadrant. So depending on how you want to do things, and there's not a hard and fast rule. So in math, we tend to always do things clockwise from the positive x-axis. I have noticed that it is more often that your books are going to express things either from 0 to plus 180 or from 0 to minus 180. So rather than adding 180 to this, I'm going to subtract 180, because if I added 180, I would get to the angle that's in quadrant 3. But if I subtract 180, then I'll get the negative angle. They are equivalent. It's not that one is right and one is wrong. It's just, it's just convention. What do we do? And our convention is that we'll keep angles between 0 and negative 180. So you'll either add 180 if it's a negative number, or you can subtract 180 if it's a positive number. So I'll subtract 180. And I get negative 146 degrees. And so my answer is 7.21, angle negative 146 degrees. Now let me show you something. I have been telling y'all that you need one of these calculators, and let me show you why you need one of these calculators. I'm going to put in -6 minus I, because on the calculator it's I, 4. And then I'll go to the complex menu, and no, that's not what I wanted to do.
Is this on the TI-84?
This is not on the TI-84. I can show you how to do it on the TI-84 though.
Oh.
It's just a little harder.
That would be nice if you could.
I will. I don't know if I will do it today or if I'll do it in a video.
Okay.
And I will go to convert to R angle theta. And there it gives it to me, and there it is. If I wanted not 2 square root 13, I could either have used a decimal anywhere in my number, or, let's see. I think I've done too many things here. Let's see. So if I did 2 square root 13, enter, and then on this calculator just press that button and it gets me 7.211. So it's very handy. So like for instance this next one, J2, I'll show you how easy it is, but just in case you forget. So if I do I2 second complex, convert to R angle theta, it gets me 2 angle 90. And that's correct. But let's see why. Okay, so J2, it doesn't have a real part. It just has an imaginary part. You go up 2. So I don't need to do any, and what's the length of this vector? It's just 2. So that's 2, and what's my angle? I don't need to do an inverse tangent. I can see that it's 90 degrees. Okay, the next one is 2 plus j squared. We're going to do this one a couple ways. So the first way is I'm going to write it out, 2 plus j times 2 plus j. I'm going to FOIL. 2 times 2 is 4, 2 times j is 2j, 2 times j is 2j. J squared, by definition, is -1. So j squared is -1 by definition. 4 minus 1 is 3, so 3 plus j4. So that is our answer. Another way to do it is to change this to polar form, and so I will get my magnitude is 2 squared plus 1 squared is 4 plus 1, or the square root of 5. And then get my angle. So my angle would be the inverse tangent of 1/2 it's 26.56 degrees. And then this then tells me, I'm going to write it in exponential form, is the square root of 5 e to the j 26.56 degrees. Now to square it, it's easier to square it if it's an exponential form, because in exponential form, to square it, I square square root of 5 and I get 5, and to square the exponent, power raised to a power, you multiply. So I just multiply 26.56 times 2, and I get 53.13, so this is J 53.1 degrees. So this is this in polar form, which you can check because we did that. That was problem 1, I think. 3 plus J4. Now, when I get to F here, 3 minus J2 to the 6th, to the 3rd power, it's definitely going to be easier for me to change this, especially if I'm supposed to give my answer as a phasor. It's definitely easier for me to go ahead and change this to a phasor and do my calculations there. It's a lot easier than multiplying it out 3 times. So the magnitude would be 3 squared plus 2 squared, 9 plus 4, or the square root of 13. My angle is going to be the inverse tangent of negative 2 over 3. Oh, wrong calculator. Although that's the calculator you want. Inverse tangent. What was it? Negative 2 over 3?
Yeah.
Negative 33.6. Negative 33.6 degrees. Let's make sure that that's in the right quadrant. So we wanted to go to the right 3 and down 2. Yes, negative 33.6 is in the correct quadrant. So this is square root of 13 e to the negative 33 point negative. I'm used to putting the I after the number, but you usually write the J before the number. I don't know why, but negative J 33.6. Now to cube this would be the square root of 13 cubed, e to the negative 3 times 33.6 J. So I would take So I want to take the square root of 13 and cube it. And that's my magnitude, so 46.87. Angle, and then I want to take 3 times 36. And I get negative 101. So negative 101 degrees. Okay, so let's see. I'm gonna, in the interest of time, I'm gonna not do the 1 to the 1/2, and I will move on unless there are questions. That was an emphatic no. Okay, all right. Okay, so now we're going the other way. We want to express the following complex numbers in rectangular form. And sometimes this is the way you have to go because, for instance, if I have different angles, it's hard to add these. It's very easy for me to add 3 plus J4 plus 2 plus J5. That's just 5 plus J9. That's easy. But if these were in polar form, it's harder to see how to do it. multiplying is easier in polar form, and adding is easier in rectangular form. So 2e to the j pi 6. So this is to go from polar to rectangular, then you're going to use that it is your amplitude A cosine theta plus j sine theta. And so it'll be 2 times the cosine of pi over 6 plus j sine pi over 6. And the cosine of pi over 6 is a square root of 3 over 2, plus the sine of pi over 6 is 1/2, plus j 0.5. And so now if I multiply through by 2, 2 times the square root of 3 over 2 is a square root of 3, which is about 1.73. 2 times 0.5 is just 1, so 1.73 plus j. You do not have to worry about the quadrant when you're doing it in this direction, because that's already taken care of for you. Because the problem with getting the quadrant was taking the inverse tangent, and we're not doing an inverse tangent here. I'm gonna do, let's see, what time is it? Okay, let's do C. So I have the square root of 3. Actually, it's the same. So there's nothing weird there. You just plug into that. But we'll look at some of the others. So I've got so for D, I have z4 equals minus j to the third. Okay, now you might say, well, that already has a j. Why do I need to put it in rectangular form? Rectangular form, you're not going to have, j is not going to be raised to any power. So you don't want to have j raised to a power. There's a couple ways to do this. One way is just to know the following. Anything to the 0 power is 1. So j to the 0 power is 1. Anything to the first power is just itself. So j to the first power is j. J squared, by definition, is -1. J to the third would be j squared times j to the first, which would be -j. J to the fourth would be j squared times j squared, which is -1 times -1, which is +1. And then it's going to repeat itself. And so you get 1j, -1, -j, 1j, -1, -j. So if you know that, and even if you forget that, you can say, well, this is -j squared times j to the first. You have to remember that j squared is -1. So that's -1 times j, which is just j. And so it was -j to the third, and j to the third was -j, and so you have that. But the other way to do it is, let's look at it in complex in polar form. So let's look at -j. So -j does not have a real part. It's down 1 on the complex axis. So in polar form, this is the length of that is 1, and then e to the j to the -j 90 degrees, because this is -90 degrees right there. And then to cube this, you'll cube the number. 1 cubed is 1. You multiply the exponent by 3, so that's -j 270 degrees. But -270 degrees is the same, -270 degrees is the same as +90 degrees. You can just add, you can always add multiples of 360. So this is the same as e to the j 90. Well, what is e to the j 90? E to the j 90 is length 1 at an angle of 90 degrees, which is right there, and that is just J, like our answer is. Or if you wanted to see it, done out in detail, e to the J90 is 1 times cosine 90 degrees plus J sine 90 degrees. Cosine 90 degrees is 0, sine 90 degrees is 1, so that's 1 times 0 plus J, which is just J. Okay, so the next thing I'm going to do is, let's say this is not one that's on your worksheet. Let's say I did whatever calculations I had, however the numbers were that they gave me, and I have 5 plus J3 times 2 minus J6. And I'm supposed to write my answer in phasor form. You can, if you're thinking back, like, well, yeah, I know I did this, multiply by the conjugate. You certainly can multiply by the conjugate, top and bottom by the conjugate. But since we have to change to phasor form anyway, it might be easier to change these to phasors right now, and then get our answer that way. So I'm going to pause for a minute, and I would like y'all to change these to phasors. Do it like show your work, like don't just use the calculator to do it, and then I'm going to show you what to do. So change 5 plus J3 to a phasor and 2 minus J6 to a phasor, and then I'll show you what to do from there. And then if you want to look, I will show you on the TI 84 while we're waiting. If I remember. First, on the TI 84, you need to make sure that you have chosen a complex format. You can't use real, so you go to mode, and I will put it A plus BI form.
Wait, just scroll down.
That's mode.
More
Uh-huh.
mode. Oh, and A plus BI.
And A plus BI. And then second quit. And then what was my number? I had and I'm going to put it in parentheses, and then my I is second decimal. So I've got 5 plus J3, that's the same as I3 plus 5. And then I'll go to math, over to complex, and change to polar. But you see, it's kind of messy and hard to read. And you don't have the option of phasor form with just the angle. But it does tell you that it is 5.8, and then what was our angle?
30.96.
30.96. And so I'll do the same with the 2 minus I6. And you get 6. Can someone tell me what I get? Two minus J6? No, you can't use that calculator. That just makes me very upset. And I hate that calculator. That calculator's bad. Bad news. It's not doing any of this for you.
Yeah, I'm just doing it to just.
Yeah, you're doing it, you're learning how to do it, which is correct. So yes, you can use it. I'm just saying, you will want, you need to know how to do it the long way because you have to show your work like on the quiz and stuff. But it is a calculator that makes me very sad. Okay, so it's 6.3 and negative. Oh, I'm in radians, huh? That's my problem. I'm in radians. I think it only gives it to you. Does it only give it to me in radians? It might only give it to me in radians, even if I change it to degrees. Oh, it does? Okay. Okay, great. So this top one was really uh, $30.96. And the bottom one, $6.3, negative 70. What was it?
6.32 e to the negative, so 1.56 at 5.
Okay. All right. So you get those two numbers, and then the way you do the division is you divide the numbers and you subtract the angles. So it would be, so this was 5.8 angle 30.96 over 6.3 angle negative 71.6. And so it's 5.8 divided by 6.3 angle 30.96 minus negative 71.6. However, you can also, on either one of these calculators, just do, so on this calculator, I'm going to do 5 plus I, yeah, you can, I3 over 2 minus I6, enter. Okay, so it gives it to me in rectangular format. And then I'm going to change that. I'll go to complex, and I'm going to change it to r theta form. And I get my answer, which I'm assuming is correct. It does, but you have to be careful. The TI-84, the problem with the 84 is that there are some things that it will only do in radians. And so if you wanted to do what we were doing right there, I don't know exactly how you went about doing it, but you're going to have to play around with it, and I have not done it recently enough to tell you which ones it is. So
I got it again.
Was it?
I was messing around and I figured it out.
Okay, all right. So another really good calculator is the TI-89, and the TI-89 does a lot of things, and I have requested from TI a workshop loan of those because they're like close to $150, $160, enough to borrow to have, like, if people wanted to come and try them out, and I would show y'all all the cool things that it does. But that
need like better calculator for future classes.
depends. Do you need one? No. Do you want one that does a lot of stuff for you? I do. I don't do things for I mean, I know how to integrate. I'm not integrating anymore. It does symbolic stuff. I'll show you and you'll be impressed. Okay. All right. So what kind of problems So I know on your quiz, what were the, I know there's the phasor stuff, but before I get to the phasor stuff, what was the first problem on your quiz? Was it, I'm not gonna do your quiz problem, but I wanna know what kind it is, so I can do something like it.
It was addition.
It was addition. Okay, so, let me see. And it says put the answer in phasor form?
Yeah.
And is it given in rectangular form?
Yeah.
Okay, so let's,
I think it's given in rectangular. One of them is given in rectangular form, and then the others are given whole.
let's see.
Honestly, the hard part was just number 2 because he didn't teach us that in class.
Okay, so,
He did, but he wasn't the way to teach
all right, well, let me, okay, so, for number 1, so, okay, I'll do things like 2, but let me just see what time it is. Yeah, I've got time. All right, so, if I had something like 5 plus 3J3 plus 2 plus J2. This is easy to add in rectangular form. It's 7 plus J5, and then I change it to rectangular square root of 49 plus 25, and my angle is the inverse tangent of 5/7. So that's easy enough. If I have it in 2 different forms, 5 plus J2 plus 3 angle 27 degrees, I'm probably going to, because it says that the directions say to only use your calculator to check your work, I'm going to change this one to rectangular. So I'm going to do this as 5 plus J2 plus 3 times cosine 27 degrees plus J sine 27 degrees. So cosine 27 is 0.89. And sine 27 is 0.45. And then I would multiply all that by 3. So this is 5 plus J2 plus 3 times 0.89 plus J times 0.45. So 5 plus J2 plus 2.67 plus J 1.35, and then combine like terms, 7.67 plus J 2.35. And then you have to give your answer in phasor form, so you'd find the magnitude and then the angle. But we've done a bunch of those, so I think I'm going to move on to the next problem. Okay. All right, so I am going to skip this one for right now. Just remember that if you already have it in phasor form, when you multiply the numbers and add the angles, and when you divide the numbers and subtract the angles. Okay, so here I need to transform the following sinusoidal currents into their phasor counterparts. Okay, so if you think about e to the I theta. That is cosine theta, or j theta. That's cosine theta plus j sine theta. It has a real part and an imaginary part. The real part is the part that is the part that is represented by the phasor. So like if you look here, we have x of t, that is our sinusoidal function. By sinusoidal, we mean sine or cosine. The sinusoidal function is going to be the real part of that complex exponential. The reason we use the complex exponentials is that they're a lot easier to work with. It's really easy to take the derivative of an exponential function. And it's easy to multiply them, it's easy to divide them. And so that's why we use these phasors, because they're easy to work with. And so when we're looking at this, we are going to turn it into something that right now this is real. And we're going to turn it into something that has a complex part. But we only mean that we're going to be using the real part of it. None of that really matters in terms of what you need to do here. So, okay. So everything we use cosines. So if I have, another thing that is kind of weird. When I write sine 8t plus 75 degrees, this is in radians. That's in radians. This, I will look and see if it has a degree symbol, it'll be in degrees. If it doesn't, it's in radians. If it doesn't have a degree symbol, then it's in radians. But you can have them mixed, and I find that kind of bizarre. Okay, so sine and cosine are cofunctions. And what that means is the sine of theta equals the cosine of theta minus 90 degrees. Or if we are in radians, cosine of theta minus pi over 2. So the first thing I need to do is to get this as a cosine. So 10 sine 8t plus 75 degrees equals 10 cosine 8t plus 75 degrees minus 90 degrees equals 10 cosine 8t minus 15 degrees. Okay, now the information that we are missing when we turn something into a phasor is the information that's right here. It's this 8. That is information that we don't get when we write it as a phasor, that at the end of the problem, when you turn it back into time domain, this has to do with the frequency. But when we write this as a phasor, we just use this number right here and this number right here. So as a phasor, this is 10 angle negative 15 degrees. Now, this number in front is always positive. So what are we going to do with part B here? So part B, and that's the answer. That's all there is to it. So with part B, I have negative 17 cosine 9t minus 25 degrees. So if I needed, I need my number to be positive. I need my my amplitude to be positive. And so I need to somehow change this so that it has the same value, but with a positive number right here. Notice that if I have an angle right there, and I have whatever the coordinates of this are, cosine theta, sine theta. If I add 180 degrees, negative cosine theta, negative sine theta. Now, it's not true for sine, but for cosine, the cosine of theta plus 180 degrees equals minus the cosine of theta. Or, if I were to use pi, the cosine of theta plus pi equals minus the cosine of theta. So I want to do the opposite here. I want to make this one the negative of what it is. So 17 cosine t minus 25 degrees. And then I can either add or subtract 180 degrees. I'm going to add 180 degrees. Do you know why I'm adding 180 degrees instead of subtracting 180 degrees? It doesn't, they both would be correct. I like my angle to be between positive 180 and negative 180. So if I subtracted 180, then I would have something that was smaller than negative 180. By adding 180, I get something between negative 180 and positive 180. It's not wrong the other because there are lots of equivalent angles. So then this becomes 17 cosine 9t plus 155 degrees. And then as a phasor, that's 17 angle 155 degrees. Yes?
You only need to do this because the cosine is negative, right?
Correct. Now, if my sine was negative, I would change it to a cosine first, and then I would take care of the negative with the 180. And now that he's leaving, I'm going to tell y'all all the secrets. And I'm going to hand out copies of the tests for the rest of the year. Okay, because the last one I'm going to do is this one, and we're going to solve this equation for I, where I and V are phasors. So, and we have these other values. So this is just like showing how you can work with phasors. They work like variables. I mean, there's nothing weird about it. So I'm going to factor out this this phasor I, and I have R plus J omega L equals this phasor Vs, or I equals Vs over R plus J omega L. Vs is 15 angle negative 120. R is 3 plus omega is 40K, and L is 0.1 milli. The K and the milli cancel each other out. 40 times 0.1 is 4, so plus J4. Oh, hey, isn't that one that we did? No, yes. So this is 15 angle negative 120, and then in problem 1, we did that this is 5 angle 53.13. And then to do this division, 15 divided by 5 is 3. And then I subtract my angles, minus 120 minus 53.13, or 3 angle negative 173.13 degrees. Oh, I was kidding. I actually don't have copies of all the tests to hand out. Yeah. Okay, are there other questions? Y'all think you know how to do your quiz? Okay. Um, did I do something wrong?
I have a question.
Yes.
For question 2, they have a pi next to the t, so we just ignore that value when we're writing the phasor form.
Let me look. I doubt it. Let me see. It probably means it's in radians. Um, oh yeah. So phasor, so the idea, it's not the phasor form, the information that you're losing is the information that is with the t, and that is the frequency. So yeah, the phasor form does not include information about the frequency. So when I was doing the ones that I was doing here, you notice I ignored the 8 and I ignored the 9 because it's not that that information is not important, it's just we don't use it when we're doing the calculations with the phasors and when we bring it back at the end. Because the frequency is not going to change throughout the problem, and so why have to mess with it all along? Okay, other questions? All right. Then I guess we're done. All right.